So we're looking at these functions with corners and these little points here. And these are non-differentiable points because as we go along here, we have a particular slope on the left, we have a slope on the right, so these have derivatives. We can calculate slope here and here. But at this point, there is no defined slope. And so when we graph this, we end up with a jump in the derivative. So here, the limit as I go, the slope limit going this way is just constant. It's going to be -1. The slope coming from the right-hand side is constant, it's equal to +1. But the limit of the slope this way and the limit of the slope this way are different, -1 and +1, meaning that the limit of the slopes doesn't exist, so that it is not differentiable at the corner. Although the point exists, okay, this is continuous through that point, the slope does not exist at that point. So we'll take a look at another example here. We have this curve, so as I drag this along the curve where it's smooth and continuous, no problem. Okay, we have very defined slope along there where it's smooth and continuous. But as I go to this corner, boom, okay, it just changes abruptly. And we can't have that. So if we were to actually graph the derivative of this, okay, so very smooth and continuous, and then changing abruptly, what ends up happening is the derivative graph will jump. And the derivative graph is discontinuous at that point, so it cannot be defined. The slope actually cannot be defined at that point. So we have the limit of the slope going from the right-hand side, looks like it's, -2 or something like that. The limit of the slope coming from the right-hand side, it looks like it's 0, but those two limits are different. So the graph of the derivative is discontinuous, and we cannot differentiate at that corner.